Method of elimination. First, we solved a system, remember that means point of intersection, of linear equations by graphing them. That was the first thing we did to find their point of intersection. Then we solved a system algebraically with the method of substitution. Today we're going to learn another method. It's called the method of elimination. So what needs to be done in a nutshell is you choose the same variable in both equations to be eliminated. Either eliminate only the x's or the y's. Let's put this. Now it's a little more complicated than the method of substitution. There's a few more steps, but there are definitely times where it's preferable to use other than substitution. But they all get you the same end goal, which is the point of intersection. Example 1, find the point of intersection by using the method of elimination. Step 1, equations must be arranged in x and then the y and then equals number, which these are, here's the x, here's the y, equal sign, number. They have to be in that order. So that step's already done. Step 2, are one pair of coefficients matching already? So here we're looking at the coefficients. Coefficients are the numbers in front of the variable. So 4 is a coefficient, 2, we're going to ignore the sign for a minute, 2 is a coefficient. In front of this x we have a 1, in front of this y we have a 1. Not the constants, those are not coefficients, those are constants. So I'm not talking about the constants right now. So looking at the coefficients, are there a pair that's matching, meaning both x's are the same? No. Here's a 4, here's a 1. Or both y's are the same? No. Here's a 2, here's a 1. So they're not matching already. So we can't say if yes, go to step 4. So this is not the case for us. If not, pick one set and make them match. So I have to either make my x's both 4s or make the y's both 2s. So the one thing I want to point out before we start is what making the match means they should have the same number in front, so the coefficient should be the same, and also the opposite sign. Now, it doesn't have to be the opposite sign, they can be the same sign, but it's a little easier. So we're always going to go for the opposite sign just when we're learning it to start here. We're going to try to make them the opposite sign. We don't have anything here that is the same number opposite sign. So we're going to pick one, and the one that we're going to pick are the x's, just because this number is smaller, 2 is smaller than 4, so I'm going to go with the smaller number. Smaller numbers are always easier to work with. So we're going to make the x's match. We're going to go with the x's. So how do we do that? Step 3, multiply one or both equations to make them match. Remember this one has, so now it's a -2 and this one's a +1 in front of the y's. I want them both to be 2's, one positive and one negative. So all I need to do is I need to take this equation right here, the second equation, I'm going to multiply everything in that equation by, multiply by 2. So let me just show you what I mean here. I'm going to write that out a little better, a little more with proper format. So my top equation is equation 1. My second equation is equation 2. So what I'm going to do is I'm going to take equation 2 and I'm going to multiply it by 2. Just equation 2. Equation 1 I'm leaving alone. So I'm going to rewrite equation 1 as 4x minus 2y equals 6. But equation 2 now is going to be a multiply everything by 2. So 2 times x is 2x. 2 times y is 2y. And students often forget the last piece, but keep going. We're multiplying everything by 2. 2 times 6 is 12. So that was step 3. Multiply one or both equations. I only needed to multiply one equation to make the match. Done. We've made the match. So now we have the same number. We have under here, we've got both of them are 2's and they have opposite signs. So now we're actually going to go to step 4 because we did step 3. Step 4 says add to eliminate one variable. This is where the title of today's topic, elimination, comes in. So I'm going to draw a line under here. Now remember when you learned how to add in elementary school, if you had 72 plus, I don't know, 14, you would add down, right? 2 and 4, and then 7 and 1, you would add like that. So we're gonna do the same thing here, we're gonna add down. So we're gonna add these. So our equation 1 and 2 are put together now, and we're adding. Put a plus sign there, just like you would have in elementary school. And we can start at the left. We could start at the right as we would have done in elementary school, but it doesn't matter. So 4x plus 2x is first, that's a 6x. Now what's negative 2y plus 2y, positive 2y? Negative 2y plus 2y, that's 0. So that has been eliminated. The y's are gone. So I could put a 0 there, 0y, but I'm actually not going to put anything. I'm just going to leave it blank because it's not a 1, it's a 0, so I can leave it completely blank. 6x, and now my equal sign must line up. That's why it was important here that we had it in the right format so that we can add like terms. And we're still adding, so we're doing 6 plus 12, that's 18. Now you're back to grade 9, maybe even elementary school. You know what to do next. Next we're going to divide both sides by 6. We're going to divide both sides by 6, and we get our answer of x equals 3. So that was step 4. Step 4 said add to eliminate one variable. We did that. We added. Now step 5, we actually just did that too. We're solve to eliminate, solve for the remaining variable. That's what we just did. Now step 6. Once you've solved for one variable, we solved for x, remember we solved for x. Once you've solved for one variable, use that to sub into one of the original equations to find the other variable. So now we have to find y. Remember, what we're always doing is we're looking for a point of intersection, we're looking for a coordinate. We're looking for where two lines intersect. Let's say we have an x and y axis like this, x-axis, y-axis. I'm looking for the point of intersection, and let's say the picture, a really crude drawing I have here is 3, 2. So every point of intersection has an x value and a y value. So we have found our x value. Our x value is 3. Now we have to find our y value. So to find the y value, it's just like we did in when we did substitution. We're going to sub into either equation. I'm going to pick equation 1 or 2. I like 2 better because equation 2, it looks a lot more simple. So I'm going to sub into equation 2. Equation 2 was x plus y equals 6. But I know what x is, it's 3. So 3 plus y equals 6. Now I want to isolate y, subtract 3 from both sides, and get y equals 3. So what I have here is an x value and a y value, and that's where, so I've finished this, I've found the other variable, I did that, and now the final statement, therefore, the point of intersection is, we always write it as a coordinate, it's 3, 3. The x and the y both happen to be 3's in this case. And step 8 says check in the equation that you didn't use in step 6. So I want to just check. Remember up here for step 6 I picked equation 2 to sub into, so I want to check just to make sure. I want to sub into equation 1. I'm going to check in equation 1, and equation 1 was 4x minus 2y equals 6. So to check, we turn it into kind of a T-chart here. Put a line through it. This is my left side, this is my right side. So I'm checking the left side here. The left side is 4 times x, my x is a 3, minus 2 times y, my y is a 3. I get 12 minus 6, which is 6. That's my left side, and my right side was just a 6 to begin with. So that means that I've checked my answer, and I know the point of intersection is 3, 3. Let's try again. Step 1, equations must be arranged in x, y equal sign, and they are. And you can tell because they're lined up. If you look at this equation right here, I've got the x's together, the y's are lined up, and the constants are lined up. So it has to look like that, or else when we go to add them, we won't be able to, because they won't be, like terms won't be in order. So step 1 is done. Step 2, are one pair of coefficients matching already? Let's see, we've got a 2 and a 6. No, they don't match. How about a 3 and a 5? No, they don't match. So we can't do that. So we don't have a pair of coefficients matching already. We're not going to skip to step 4. If not, pick one set and make them match. And we're going to do that by looking at step 3. multiply one or both equations to make them match. So let's say I wanted to make the y's match. Well, now you're thinking of kind of like a common denominator. It's that kind of idea. You have a 3 and a 5. You need to think of what number I could turn them both into. And if you just multiply by the opposite number, it will work. So if I multiply this equation by 5 and multiply this equation by 3, these will both turn into 15s. And then they'll match. And all the other numbers will change too. But I can make it easier than that because the 2 and the 6 can match if I just take equation 1 and multiply it by 2. If I just take 3, if I multiply equation 1 by 3, that'll give me a 6 here. And that's what I want. I want them to match. Remember, 1 has to be positive and 1 has to be negative. So I'm going to multiply by -3 because when I go to add 6x and 6x, if I were to add that, I would get a 12x and it wouldn't be eliminated. So I'm going to multiply by a -3. I could actually subtract instead of adding, but as I said, I'm not going to go through that method here. So equation 1 and equation 2. Let's change equation 1. Equation 1 is now, multiply the 3 times the 2 first. That's -6x. Multiply -3 times -3y. That's plus 9y. Multiply -3 times -12 equals positive 36. Equation 2, I was able to leave that alone. I didn't have to multiply it by anything because my x's are going to match here. Okay, so there's step 3. Multiply one or both equations to make them match. Step 4, add to eliminate. So I'm going to draw a line here and add. So we add down -6x plus, so there's plus, -6x plus 6x, that's eliminated. It's gone, it's a 0. What about 9y plus 5y? That's 14y. And -36 plus -8. So, sorry, positive 36 plus -8. That is 36 minus 8. What is 36 minus 8? It's 28. And now we have one more step, and that is to isolate y. So I did step 4, now I'm on step 5. I'm solving for the remaining variable, and I get y equals 2. That's step 5 done. Step 6, once you've solved for one variable, we did that, use that to sub in to one of the original equations. So I can pick equation 1 or equation 2 from the original equations, and I'm going to sub in. You usually pick the one with smaller numbers. That's kind of doesn't really matter. I'm going to pick equation 1. So I'm going to sub to find, now I'm looking for x. To find x, because I already found y, we sub y equals 2 into whatever equation you want. I'm going to pick equation 1. Equation 1 was 2x, the original equation 1, not the one that I changed, minus 3y equals -12. But in for x, I'm going to put a 2. So we have 2x minus 6 equals -12. Now I need to add 6 to both sides so that I can isolate x. I get 2x, these are gone, equals -6. And the last step here is to divide by 2. And I'm running out of room, put it here, x equals -3. So for the final statement, therefore, POI, point of intersection, is x goes first and then y. And notice I didn't put the step 8 here, which was to check, but you can always check if you want to. But the question, if it doesn't ask you to check, you don't have to check. All right, let's move on. I'm going to just erase this so that I can see my bottom line a little better here. For the systems below, determine which variable is easy to match coefficients for And how would you achieve this? Let's look at equation 1. Equation 1 and 2 in our first system. Remember, a system means more than one line. So these are two lines. Which variable would you try to match? So would you try to match the x's or would you try to match the y's? I think probably we'd try to match the x's, because to make the x's match, we would have to multiply equation 1 by 3. So to make these match, I want to turn them both into 6's. I want them to be 6. I need one to be positive and one to be negative. So right now they're both positive. So let's say I multiply the top equation by 3. I'll get a 6x there. For the bottom one, I'm going to have to multiply it by 2, but I want it to be negative 6. So I'm going to multiply it by a negative 2. But that's all I want to just talk about in these next few ones, is just which variable would you pick and how would you do it. That's all we're looking at here. We're not going to go ahead and solve. Second step. Which variable? The x's or the y's? So we've got a 4x and a 9x. So if I made those match, what would I multiply them by? So you just would multiply them by the opposite number. Multiply one row. This row we would multiply by 9. This row we would multiply by 4. Those are going to give us big numbers. What if we chose to match the y's? If we chose to match the y's, we'd have to multiply the top row by a 2 to turn this into a 14, and we'd have to multiply this by a 7 to turn that into a 14. So I think maybe making the y's match is easier because I'm multiplying by 2 and 7 instead of 9 and 4, but it doesn't matter. In both cases, I have two positives here with the x's. I would have had to multiply by negative, and here I have both negatives. I would have to make one multiply by negative as well. So let's make the y's match. To make the y's match, I'm going to multiply equation 1 by a negative 2. That will give me a positive 14. And I'm going to multiply the bottom equation 2 by 7. And that's going to leave me with a negative 14. So then I would be able to eliminate the y's. Okay, now how about the third set? These ones. Which variable do you want to match? The x's or the y's? I think the x's look easier. A 3 and a 2, those are nice small numbers. 2 and a 5 getting a little big. So let's make the x's match. We're going to make the x's match. And how would we do that? We'd multiply them by whatever the other number was. So this is a 2, which means I have to multiply the top one by a 2. The first one has a 3 in it. I have to multiply the bottom one by a 3. That will give us, again, 6's. Remember, one needs to be positive and one needs to be negative. It doesn't matter which one. They're both positive right now, so I can pick the top to multiply by a negative 2, and the second equation I can multiply by a positive 3. That would give me a negative 6 and a positive 6x, and they would eliminate. Okay, that's just practice with making getting the equations multiplied by the right value. Example 3, find the point of intersection and check your solution. Okay, we're going to use the method of elimination, of course. I was going to say substitution. So I want to eliminate. So first I need to look at the variables. Do I want to make the x's match or do I want to make the y's match? I think it's easier to make the y's match because they're smaller numbers than it is to make the x's match. But it doesn't matter. On a test or a quiz or in your homework, you do whatever one you want. You're still going to get the same answer. So this is equation 1 and this is equation 2. I want to turn I want the y's to match, so I need to take the top row and multiply it by 3. The bottom equation needs to be multiplied by a 2. Now, will we have one positive and one negative? Remember, that was one of our rules up here. We have to have opposite signs. I noticed I didn't retype all the steps for you here, but we're still following the same steps. So step 2 we're on right now. We need to have opposite signs, so we have to go to step 3, multiply one or both equations to make them match. Multiplying both equations to make them match. So my equation 1 is now 3 times 3x is 9x. 3 times 2y is negative 6y, equal sign, and don't forget the last one, 3 times 2 is 6. Equation 2, 2 times negative 10 is negative 20x. 2 times 3y is plus 6y equals, and 2 times 8 is 16. So that was step 3, multiply one or both equations to make the match. We did that. Step 4 is add to eliminate one variable. So notice that our y's match, one is positive and one is negative, and we needed that to happen. So step 4, add 9x plus negative 20x. This is 9x plus negative 20x, which is 9x minus 20x. That's negative 11x. Negative 11x. Negative 6y plus 6y. Negative 6y plus 6y. Of course, that's 0. So they are eliminated. The y's are eliminated. And then the equal sign, very important. 6 plus 16 is 22. Now we're trying to isolate x. Divide both sides by negative 11. Negative 11. And we get x equals negative 2. And you think, that's great, I'm done. You know now, you're not done. We're looking for where two lines cross each other. And where two lines cross each other, we have a point of intersection. We have a coordinate, an x and a y. All we have is the x. We need the y. So how do we do that? Look at your step 6. Once you've solved for one variable, we did that. So once you've solved for one variable, use that to sub into one of the original, either one of these two. So you can sub into equation 1 or equation 2. So I would like you to do that right now. I want you to press pause and I want you to pick equation 1 or equation 2, sub into it, do that yourself, and then when you come back you'll see the answer. I hope you did that. I subbed into equation 1, that looked a little easier than equation 2, and I got x equals negative 4. So that means my point of intersection, POI, is x comes first, and then, whoops, I wrote x twice there, that's a y, sorry. X comes first, and my x was a negative 2. Negative 2, and then the y is a negative 4. Question says check your solution. So I'm going to check, I'm going to go up to equation, I already, remember I subbed into equation 1 here, so you check in the other equation when you do your check. I'm going to check in equation 2, and equation 2 was negative 10x plus 3y equals 8. So we turn that into a left side, right side thing. So a line, whoops, let's make that straight. Okay, so now I've got my left side here and my right side here. So I'm kind of ignoring this equal sign in the middle right now. Negative 10, and what did we get for x? We got a negative 2 plus 3 times y, and what did we get for y? We got a negative 4. And let's work that out. That negative 10 times negative 2 is 20. 3 times negative 4 is minus 12. 20 minus 12 is 8, and my right side, of course, is also an 8. So it works out on equation 2. That means that 2, negative 4 is the right answer. So that's the method of substitution. Please follow the steps that I gave you here when you're trying to do your own questions.